Hi everybody, welcome to physics teacher classes. What is our topic? Kinematics. It's a very important chapter in physics, Nana. Okay, now so far you learnt about distance, displacement, speed, velocity, everything. Today we are going to learn a new one, that is acceleration. What is that? Acceleration. Very important concept. You listen carefully. So what is meant by acceleration? Okay, first let me give its definition. So it is defined as a rate of change in velocity. Rate of change in velocity of an object. Very simple definition. What is this? Rate of change in velocity. Here two things are there. One is a change in velocity rate. Okay, with respect to what we are identifying the change in velocity with respect to time. Here that rate is time rate. Okay, so time rate of change in velocity, or simply rate of change in velocity, is acceleration. Let us see that there is an object. Okay, this is an object at A. Now this object is moving, right? Okay, to point B. At A, its velocity is u meters per second, suppose. At point A, what is the velocity of the vehicle? U meter per second. After reaching B, the velocity of the body is v meters per second. Okay, after B also moving the body, before A also the body is moving. Somewhere it is coming, from somewhere it is coming. But I have started observing from point A till point B. I have observed the body. Very important this is. Okay, sir. The body is coming from somewhere and moving to somewhere. But in between 2 points I observed, from point A to point B. At point A, its velocity is u meter per second. At point B, its velocity is u meter per second, v meter per second. Before point A, it has some velocity, x meter per second, something and something. After B, it has some velocity. Okay, z, x, whatever. But my observation is from point A to point B only. Now here, at A, the velocity is called initial velocity. What is this? Initial velocity of the body. That is how much? U meters per second. Remember that. Initial velocity means at your point of observation. Before that also it has. I am not taking that as initial velocity, because at point I am observing the velocity of the body, that is called my initial velocity. Okay, so point B, at point B the velocity is very good, final velocity. Okay, that is how much? V meters per second. After that also it has. Okay, now after B also it has velocity. But my observation ends at point B. Starts at A, ends at B. So at A, initial velocity, at B, final velocity. Clear? Very good. Now, what is the change in velocity here? What is the change in velocity? Change means what, sir? Final minus initial. Yes or no? Always if you calculate any change, means final minus initial you are doing. Here what is the final velocity V minus what is the initial velocity U? Got it? Then rate of change in velocity. What is that? Rate of change in velocity, sir. Rate of change in velocity. What is that? Change in velocity divided by time. That means you observe a time t. Understood? So at A you start at time 0. At B the time is t. Then what is your observation time? T seconds or something. Okay. Then rate of change in velocity is v minus u by a t. Then rate of change in velocity is known as acceleration. What do you call this as? Acceleration. So acceleration is equal to what, Nana? V minus u by t. Therefore acceleration is denoted with letter A. It is a vector quantity, that is velocity, final velocity minus initial velocity by time. Understood? This v minus u you can write as change in velocity as delta v. Okay, this delta represents a small change. This represents a change in velocity. Delta v means change in velocity. Delta x means change in x. Delta y, change in y. Delta f, change in f. Okay na? So similarly, a is equal to delta v by t. You can write delta v is nothing but v minus u. So this is a acceleration definition and a mathematical formula of acceleration. So acceleration is nothing but what, Nana? Change in velocity divided by time. Very simple. What is the acceleration? Change in velocity divided by time. Now let us see what are the units of velocity, acceleration. Okay, so we have formula. What is the formula? Change in velocity by time. Right, Nana? So first, what is the velocity unit? Here change in velocity is nothing but, after change in velocity, what do you get? Velocity only, na? 4 meter per second minus 3 meter per second, 1 meter per second. So what is the velocity, change in velocity's unit? Same as velocity. So what is that in MKS? Meter by second. Velocity unit is meter by second. Divided by is there, na? By. What is the unit of time in MKS? Second. So that, what is the unit of acceleration MKS system? Meter by second into second, second square. Clear? So the unit of acceleration is meters per second square in MKS and SI. SI unit also same. What about in CGS system? Centimeter by second square. Centimeter by second square, that's all. Okay, now you can convert 1 meter per second square is equal to how much? 100 centimeter per second square. This is the conversion. Understood, Nana? So now we learnt definition, formula and units of acceleration. Right, this is not enough for acceleration. More things we need to learn about acceleration. Here, change in velocity divided by time. Acceleration is nothing but what? Acceleration is nothing but what? Change in velocity divided by time. Yes or no? Right. What is meant by change in velocity? Change in velocity means what? When you can say the velocity of the object is changed. This is very important. Okay? When can you say velocity of an object changes? Okay, no. Now I'll give some examples. Okay, some situations. Now try to identify in which case the velocity of the body changed. Okay, and now tell me first case I am taking. So an object, this is an object, okay, moving with a speed u meters per second, okay, from point A to B. Here it is v meter per second. And second case, okay, this is the first case. And in the second case, now this is the object, okay, moving east with a velocity u meter per second. Right, Nana? So after moving to point B, it moves towards north with the u meters per second. This is the second case. It is moving towards east. After that, it moves towards north. Second case. Okay. Now third case. You take a rubber ball. This is a rubber ball. This is the wall. This is the wall. I am hitting the rubber ball towards the wall with a velocity u meter per second, with a speed u meter per second. Okay, after hitting the wall, it is coming back with the same speed of u meters per second. With the same speed of u meters per second. Understood, everyone? Okay, these are the cases. Next, let us see fourth case. Let us see fourth case. So here, the body is moving like a ball. It is moving with a speed of u meters per second east. After traveling some distance, it turns and moves with a speed of v meter per second for some time. Okay, now tell me, in which of these following cases velocity of the object changes? I have given 4 cases. In which of the following cases velocity of an object changes? Okay, now you note down which cases you are. 1, 2, 3, 4. Just note down on a paper. Let us see. Okay, so first see here, velocity is what? It's a vector quantity. Yes or no? Means it has magnitude and direction. We know that. If the magnitude changes, velocity changes. If the direction changes, velocity changes. Both changes, velocity changes. Understood? Now see in the first case, the direction is constant. It is moving towards east. But the magnitude is changing. U, here V. So that there is change in velocity. Yes or no? Yes, though the change in velocity is not 0. Understood? So here change in velocity is there because the magnitude is changing but the direction is not changing. Are you understanding or not? Here the magnitude of the velocity is changing, u to v. So there is a change in velocity but the direction of the velocity is not changing. Even though magnitude changing, velocity changes. Here only magnitude is changing. Now coming to second case. First it is moving towards east. Okay, next it changes to north. Okay, here magnitude is constant. What about direction? Direction is not constant. First it is moving towards east, next it is moving towards north. So direction is not constant, therefore change in velocity is not 0. There is a change in velocity. Are you understanding or not? There is change in velocity because here magnitude is constant but direction is changing. If magnitude and direction both are same, then only velocity is constant. Velocity is not changing. When velocity is not changes, when the magnitude and direction both should be constant. Okay, sir? Now coming to third case. See here, initially the velocity is towards east with the u. Next the velocity is towards west with u. Magnitude is same but the direction is changing. So that change in velocity is 0 or not 0? Not 0. There is some change in velocity. Clear? Now coming to fourth. Here which is changing? Magnitude or direction? Direction. Okay, here which is changing? Direction. Here which is changing? Magnitude. Clear, Nana? Now in this case, first it is moving with the u meter per second east. Next its velocity changes in magnitude and direction. Okay, its magnitude changes from u to v and its direction changes from east to north. So here magnitude is changing and direction both are changing. So then change in velocity is not equal to 0. Got? That means in these 4 cases there is change in velocity. I think you got a clarity on this. When can you say velocity is changes or velocity is changing? Okay, now you see an example. This is a body moving with 3 meter per second and after some time also it is 3 meter per second. In this case, what is the change in velocity? Is it 0 or not 0? In this case, change in velocity is 0 because magnitude of the velocity is constant and direction of the velocity also constant. Magnitude is not changing, direction is not changing. Condition satisfied. So change in velocity is 0. That means here velocity is constant. Velocity is constant, I can write. Clear? So in these are the cases velocity is changing. Then how to calculate change in velocity? How to calculate change in velocity? So it is very simple to calculate change in velocity. Now let us see the first case. In the first case, what is the change in velocity? First you observe their directions. Their directions are same. Okay, then what is the change in velocity? Final velocity minus initial velocity, meters per second. That is the change in velocity here. Got it? Final velocity minus initial velocity, because both are in the same direction, so only magnitudes are different, right? Now second case. So here initial velocity is u meter per second east. Okay, next final velocity is towards north, u meter per second. Are you understanding or not? Okay, this is u and this is u. Now how could I get a change in velocity? Okay, here magnitudes are same but directions are differ. So for this we will be using vectors concept. Understood? So this u I can write here. Now these are co-initial vectors. What is the resultant velocity? Is nothing but the change in velocity. So the resultant change in velocity will be in this direction. Okay, now clear? Now how to calculate this? Root over u square plus 2u into cos theta. Okay, now then that is u square plus 2u square into cos 90 value how much? 0. So that it will be 0. So that you will be getting as a u into root 2. That is the change in velocity in this case. How much, Nana? U root 2. Can I explain here? Yeah, see this. So this is u and this is u. Okay, this is the resultant. Okay, now how will be this? This angle is theta is 90 degrees. Now change in velocity what? U square plus u square root over kada plus 2 into u cos theta. It like parallelogram la magnitude of vector is p square plus q square plus 2pq cos theta, right? That is u square plus u square. I can write 2u square plus cos theta, cos 90 is 0, so this is 0. Okay, na? So this is 2u square root over, if u comes out then it will be what? U into root 2 meters per second. This is the change in velocity in this case, sir. Got it? Right. Coming to third case. Now first initial vector is this side, next final velocity is this side. What is the change in velocity? Final minus initial. What is the change in velocity? Most of the people will write 0 here. It is not 0. Why? These two should be in the same direction to add or subtract. Okay, then you change this vector, final velocity vector, into this side so that it is minus u. Now what is the change in velocity? Final velocity minus initial velocity. Final velocity is minus u, initial velocity is u. Then how much, sir? Minus 2u meters per second is the change in velocity in this case. Okay, if it is 3 meter per second and again coming back with 3 meter per second, what is the change in velocity? Don't say 0. Okay, velocity is a vector quantity, be careful with that. Okay, be careful with the direction. See the initial velocity direction, see the final velocity direction. Okay, both are opposite. Then what do? Then you take any one vector's direction as positive, other vector's direction will be negative. I have taken east as positive, then west will be negative. Okay, that's why I have changed it. This is the answer. Got it? What about this case? Same in this case, but here u square plus v square plus 2uv cos 90 root over. Yes, what do you get? Root u square plus v square root over. This is the change in velocity. Because cos 90 is 0, this value is 0. Root over u square plus v square is the change in velocity. Got my point, Nana? So in this way, we can calculate a change in velocity. Clear? Now here tell me, what is the direction of change in velocity? As velocity vector, change in velocity also vector only. What is the direction of change in velocity? This is east and this is east. This is east. Okay. Now in this case, what is the second case? Change in velocity direction. Okay. This is the change in velocity direction. What direction is this? East, north. This is northeast. Got it? Because it is 90 degrees. right? Nana. Next here, what is the change in velocity? You take east as positive. East is positive, you have taken. West, negative, you have taken. What you got the answer? Minus 2u. This can be minus 2u in which direction? East, or else 2u west. This is the change in velocity direction. Understood or not? Minus u, minus of u. Minus u is the final velocity, u is the initial velocity. You got minus 2u in the east direction. Okay, no, sir? So that is. Next here also, that is northeast. Northeast is the change in velocity direction. Clear? Very good. If not, once again you just pause the video, go back and see the change in velocity concept. Very, very important one. Okay, now? Very good. Now, let us come to our topic, acceleration. Okay? You learnt about acceleration definition, okay, and mathematical formula, that is v minus u by t, and units also you learnt. What are the units? In MKS it is meter per second square. In CGS it is centimeter per second square. Is kilometer per hour square unit of acceleration or not? Yes, it is unit of acceleration only. In place of meter, centimeter, it is kilometer, second square, hour square. This is also unit of acceleration, no doubt in that. Now let us see, as acceleration is a vector quantity, it has magnitude and direction. Okay, na? This gives the magnitude. What about direction? What about direction of acceleration? The direction of acceleration is the direction of, listen carefully, direction of change in velocity. Change in velocity. Understood? What is the direction of velocity? Sorry, direction of acceleration. The direction of acceleration is in the direction of change in velocity. If the change in velocity is east, acceleration direction is east. If the change in velocity is west, acceleration is west. If the change in velocity is northeast, acceleration is northeast. Remember that direction of acceleration is not velocity direction, sir. Change in velocity direction. Be careful. Okay, na? So this. Now let us see the direction of acceleration, how it is changing. For example, this is an object has a velocity u meter per second. Okay, after traveling some time, its velocity becomes v meter per second. Here v is greater than u. V is greater than u. What does it mean? It means the velocity of the body is increasing. Yes or no? Okay, velocity of the body is increasing, so that you can say the body is accelerating. Okay, because the velocity is changing. When the velocity is changing, we can say that body is accelerating. Clear? So then, what is the change in velocity direction? East. This is the acceleration direction also. What is the motion of the body? This is the motion. The direction of motion and the direction of acceleration are in the same. When the velocity of the body increases in a straight line. Got my point? Here acceleration and direction of motion are in the same direction. When the body is increasing its velocity in the same direction. Okay, this is, you can see many examples. When you are starting your car in a straight line, when you are starting your car, its velocity is 0. Yes or no? When you are starting from rest, when a body is starting from rest, its initial velocity is 0. Remember that. Because before you start that, it has no velocity. So whenever a body is starting from rest, its initial velocity is 0. This is the condition. Similarly, when a body comes to rest, then its final velocity is 0. Because the body is coming to rest finally. Okay, coming from somewhere and stopped there. Understood? So now you can see one example. A train is starting from a station. A train starting from a station. Is it an example of acceleration or not? Yes. Okay. So as the train is starting, its velocity is 0. Slowly it picks up speed. Yes or no? It is accelerated motion. No doubt in that. So the direction of acceleration and the direction of motion will be same. Okay. Now a train coming to station. Okay, now when a train is coming to station, it comes fast, slowly decreases and finally comes to stop. Yes or no? Here this is the direction of motion, but what is the direction of acceleration? Direction of acceleration is this. Okay, now acceleration direction is this, motion direction is this. Here the direction of acceleration and motion are different. Here the body's velocity is decreasing. Velocity is what? Decreasing. Understood? When the body velocity decreases and it is going in a straight line, the motion and acceleration directions are opposite. When the body's velocity is increasing and the moving in a straight line, acceleration and motion are in the same direction. Okay, sir. So this is called as a negative acceleration. Negative acceleration, or this can be called as a retardation. What can you call that as? Retardation. Okay, acceleration, opposite of acceleration is retardation. If acceleration is a, nana, don't confuse. Okay, if acceleration is equal to a, okay, then what is retardation? Is equal to minus a. Retardation is minus a. For example, acceleration of the vehicle is 2 meters per second square east. Okay, what is its retardation? Retardation is nothing but minus a, that is minus of 2 meter per second square east. Yes or no? Minus of, because acceleration is this, retardation is nothing but minus a. Okay, minus 2 meter per second square east. It can be written as, come on, tell me, 2 meter per second square minus is nothing but opposite to east is which direction? West. Therefore retardation is 2 meter per second square west, when acceleration is 2 meters per second square east. Understood? Okay, if acceleration of the body is something is given, that is a. If retardation of the body is giving something, that is a is equal to minus. Are you understanding or not? Okay, na? Very good. So in this way one can identify acceleration direction also. Clear? Now let us see some numericals based on this. First we start with the basic numericals. Okay, Nana? A body starts from rest. Starting from rest. After 4 seconds, it is observed its velocity will be 5 meters per second. Then I want to calculate acceleration. Okay, a body is starting from rest. After traveling some time, its velocity is found to be 5 meters per second here. Here what is that? 0. So initial velocity is 0, final velocity is 5 meters per second. How much time it has taken? 4 seconds. Okay, then what will be our acceleration formula? Acceleration is equal to v minus u by t. Yes or no? Right. What is the final velocity? Both are moving in the same direction. Yes or no? So 5 minus initial velocity 0 by 4 time. So 5 by 4 meter per second square is the answer. Is the acceleration of the body. Got it or not? Yes. So next see another example. Okay, now a body is moving with a speed of 10 meters per second. After 5 seconds it comes to rest. it comes to rest, means the final velocity is 0. I said already, comes to rest means what? Final velocity of the object is 0. Okay, in this case what is the acceleration? V minus u divided by time. Only v is how much? 0 minus u 10 divided by 5. What is this? Minus 10 by 5. What is this? Minus 2 meter per second square. See here, you got acceleration value negative. You got acceleration value negative, means minus 2 meter per second square you got. Okay, acceleration is minus 2. Is it accelerating or retarding? It's retarding. It's retarding, or it's retardation, means the velocity of the body is decreasing because the application of brakes or something, some force is acting in the opposite direction. This motion is called retardation, retarded motion. When the velocity of the body decreasing, its motion is retardation. When the velocity of the body increasing, it is called accelerated motion. Accelerated motion, retardation. Acceleration, retardation. What is retardation in this case? A is equal to 2 meter per second square. Very good. Acceleration is minus 2. Retardation is minus of minus 2, that is plus 2. You got it. That's it. Okay, no. Acceleration is minus 2. Retardation is nothing but what? Minus a. That means minus of minus 2. That is how much? 2. 2 meter per second square. Clear? In this way, one can calculate numericals on accelerated motion, acceleration simply. Clear? Now, for example, let us see another question. Nana. A rubber ball is thrown towards a wall. Towards a wall. Okay. Now, its velocity is 5 meters per second towards this. After hitting the wall, again it rebounds. It is rebounds and coming in the same direction. Sorry, coming in the opposite direction with a speed of 12 meters per second. Now, what is the change in velocity? I want to calculate. Change in velocity is nothing but v minus u. Now, first you write what is initial velocity and final velocity. Initial velocity I am taking 5 meters per second east. Yes or no? Right. What is final velocity? 12 meters per second west. You take east as positive, west as negative. Then v will be what? Minus 12 meters per second east. Can I write or not? Now you subtract. So that delta v is equal to v minus 12 minus u 5. How much? Minus 17 meters per second. What is the direction? East. What is the direction? East. Because it is east, it is east. Okay. Or else change in velocity is 17 meters per second west. Okay. Because minus east means opposite to east. What is the direction? West. Got? This is very important, sir. Here, this is west. Final velocity is west. I have changed it to east because I cannot add or subtract. Okay, I should make into same direction. First, let us see, they must be in the same direction. Okay, to put into east, then I should keep a minus symbol because opposite to west direction is east. So, minus east. Now, both are in the same direction. Resultant also will be in the same direction. So, I got it is minus 12 minus u as 5. So that minus 17 meter per second. What is the direction? It is east and this is east. So it is also will be east. So change in velocity is minus 17 meter per second east. Or it can be written as minus east can be written as west. So 17 meter per second west. Understood? So in this way you can calculate so many numericals on acceleration, change in velocity. Understood, Anna? Be careful while working with any vector physical quantity. Any vector. Be careful because it has direction. It has direction. So when direction is there, carefully you observe the directions of the bodies. Otherwise your answer will be wrong. Understood? So if I take this also positive, then what do I get? 12 minus 5. Simply 12 minus 5, how much? Yes. Okay, so that is that. Are you understanding or not? So while working with vectors, direction is most important. Clear? So this is today's class. You subscribe my channel. Most of the people are not subscribed and watching the lessons. You subscribe my channel. Not only that, you share it to your friends. You have many friends. So at least you share it our channel to 10 members today. Okay, that is the only thing you are doing for me. I am expecting only that from you. Share it so that our channel reaches to all members. All members will be getting benefited from that. Understood, Nana? So if the members are more, then they will be getting different kinds of questions, so that we can discuss that later. Clear? Yeah, thank you very much.